So my name is Chad Kenney. I'm the CTO for the Americas for Pure Storage. I joined Pure pretty early on. We were about 30 people in a small little room going to take on the storage world. And it functionally was all about trying to find mechanisms to alleviate consumers' challenges with overall storage. Not only just the end consumers of infrastructure, but also the application side of the house. You'll see a lot of fun stuff as we continue to evolve, but just to give you some high levels of the business over the last 6 years, we hit $1 billion in revenue last year, which is exciting for us. We're the fastest company in infrastructure to ever hit $1 billion. We're continuing down that path. We're fully profitable last year as well, which was exciting for us as another big milestone. What we're gonna go through today is actually an overall message of where we're headed as a business. And we're going to dovetail that completely into a pretty deep session around what you should be thinking around for artificial intelligence, machine learning type systems. We'll start off kind of a little bit on the higher level of just what applications we're deploying and areas of focus. So if you look at the world as it exists today, it's quite different than it's been in the past. The explosion of data is really based upon the fact that large-scale systems that are algorithms themselves are generating more data than the humans out there in the world. People are starting to look at all sorts of different solutions out there for the whole Internet of Things model of deploying solutions to be able to get intelligence closer to the edge, also bringing back deeper learning back to the core. Gartner believes by 2020 about 80 to 90% of applications will incorporate some sort of analytics engines or AI infrastructures within it to make better decisions for that particular application. But most of this infrastructure is not very simple. In fact, it's quite the opposite. People want this cloud experience that's very agile, can deliver on demand, and bring that intelligent factor, but it's pretty fragmented just as a whole if you look at most of these systems. In fact, this is what most people's infrastructure looks like, and we looked at this from the very beginning. Production environments have multiple different silos that are broken into. You've got analytics environments with a data warehouse, maybe some appliances, and maybe even you've built out your own big data lake. Your backup environment's got multiple different appliances within it that are either built for specific applications or just been built based upon the need at that time. And then your dev test environment builds out multiple different things, whether it's on-prem storage or cloud storage. If you look at what analytics really requires just as a whole, is the breaking down of barriers in order to be able to look at old historical information as well as newer information that's coming streaming in from your applications. There is no longer any cold data out there. That's a little bit of a weird concept to think about, but we have customers who are going back 15 years into surveillance data to try to get better mechanisms of understanding how consumer trends have changed within their stores and how people shop today versus what they did 15 years ago. Understanding those trends allows them to be able to create better behaviors for customers to be able to buy things easier from them. When you look at infrastructure, one of the biggest challenges that people had is they were focusing on the storage array. And really, infrastructure should be somewhat invisible. It should enable folks to be able to just leverage APIs, similar to what you do in a normal cloud environment. We believe that this is more of a data-centric architecture just as a whole, focusing in areas of being able to consolidate at high rates. Our systems today give you right around a petabyte and 3 rack units. We're able to achieve 3 petabytes and just about 6 rack units within a single system. We want real-time access to this data set, so we want to democratize NVMe-based solutions of all flash at an economic value that's about the same as your 10 and 15K spend today. We want it to be self-driving. You'll see a lot of our cloud-based management systems enable proactive management, but also predict issues before they occur. In a multi-cloud world, people want to be able to leverage and consume services both on-prem and in the cloud. And so enabling facilities to be able to move data back and forth between those environments so that applications can truly take advantage of the data sets become vastly important. And then you also need to be ready for tomorrow. We built in a consumption model that allows folks to be able to get the credit that they paid for in their existing system and never rebuy the same thing again as they continue to progress, and we'll get through a lot of these. Our areas of focus are, first and foremost, simplifying everything in production. We made it really, really easy. We no longer have RAID groups, aggregates, configurations, performance tuning, tiering. None of that exists within the product. We made it so that everything self-tunes, self-heals, and manages itself. You get visibility into all of the metrics that you need to be actionable on, but we actually leverage the support facilities to be able to give you proactive support within this. The areas of focus here are getting critical applications such as SAP, Oracle, MySQL, SQL Server from Microsoft, and get those tier 1 applications to have low latency with great data reduction facilities so that you could actually leverage them widespread within the environment and get that low latency experience associated to it. We also see that folks are looking to restore data quickly. An interesting fact, backups typically take a sizable amount of time to complete. You guys probably deal with these all the time. The restoration time's even worse. What if your restoration time could be 4 times faster than your backup time? Now, if you look at it, most people don't restore until it's a desperate scenario. And so they never built backup systems to actually focus on the restoration process. We built in an architecture within FlashBlade, which you'll see for our data hub componentry, that allows you to not only do big data analytics, AI, but also back up to this thing and get some pretty staggering restore rates. We have a 20 rack unit, 8 petabyte backup machine that actually restores 50 terabytes per hour. Your normal backup system could barely even get a terabyte in an hour if they're lucky. And so focusing on the restoration process has been very big in the production environments. We've included all sorts of software feature sets for both active-active availability and a symmetric factor, and also asynchronous replication across multiple different sites, and then being able to actually tier that data off into the public cloud or replicate them out to the public cloud as well. Our developer community is growing, and in fact, I'd say the storage admins slowly are kind of being replaced with developers. We're seeing them move up the stack. They want to automate and orchestrate things. They want to script things. They want to become that next-gen developer who's building infrastructure as code, less just building infrastructure. And so things that we've been building a lot of work around is, first, automation and orchestration tiers. We built in Ansible, SaltStack, all of the facilities around our REST API. We also incorporated a bunch of abilities to be able to parallelize an application so that you can develop quicker. Our snapshot technology, integrating with the Kubernetes and Docker engines with an abstraction layer, which we'll go through a little bit later. The last part is probably the most interesting these days. How do we continue to enable AI infrastructures so that people can leverage large-scale data sets? You'll see later in this presentation that you have kind of this growth model as data continues to increase. Older models back in the day actually didn't get a lot of value out of increased data sets. Newer models today actually get more and more value and higher predictability with larger scale capacities. And so being able to consolidate this all down into one single platform becomes quite important. Some of the areas that people have seen great success in, let's look at ConocoPhillips just as an example. They went from about 16 racks of disk down to just a couple. The data center called them the day we turned everything off and freaked out saying the data center just dropped 4 degrees. Something dramatically bad must have happened. No, they just got better infrastructure that didn't take as much power, cooling, and rack space. Domino's Pizza, not known for the most innovative companies in the world, went through a massive revolution of digitizing their infrastructure. They made it so that people could actually order via your watch. I've never done this myself, but apparently it's possible. And you can just, contact them directly from all sorts of apps to get it done. Most of their infrastructure today is all AI-driven from their ordering system. When you call into Domino's Pizza, you call a 1-800 number that goes to one single place. It finds out where you're located, transcodes your voice to figure out what your order is, and then sends it to the local Domino's Pizza that's closest to you. It's creating solutions for people so that they don't have to figure out where my closest Domino's Pizza is and do they deliver to my address. Other areas that are quite interesting are people are monetizing these types of systems. Nielsen, as an example, they are a large-scale consumer analytics company which looks at how much time are people spending on websites or TV channels or seeing advertisements, and then consumer experience of things. They were running a report that was a large batch process that took about 19 hours to complete. They delivered that report to their consumers once every 24 hours. So if you're a customer of Nielsen, you'd get a report daily on what your consumer behavior was. That report went down from 19 hours to about 8 minutes on Pure. They now do an hourly report, and they charge even more for it. And now they've created new business lines based upon the advantage that they get around performance and harnessing that true data set. The AMG Padronis team is a pretty fun one. How many people are F1 fans out there? Awesome. There's one coming up here in Austin that should be pretty spectacular. These guys run about 200 different sensors within the cars. If you check this out, there's a thing called a Pure Pit Wall. It actually lets you see all of the analytics for the race at any point in time. They were running, it was actually 3 NetApp arrays, 3 racks of them with the car. And so they kind of truck these things around. If you look at the pictures of it, we have about 6 rack units worth of flash arrays that actually sit right next to the cars. We had to build these like containers that didn't allow the carbon brake dust to actually, arc the system, so they have their own internal systems. But allowing them to create tuning in real time on the cars themselves and actually do analytics against that in real time and allow multiple systems to actually hit it at once. So most of you are probably asking, okay, so a lot of cool stories around Pure, what the hell do they actually do? So we don't like to talk a lot about boxes and infrastructure because it's really not all that sexy, to tell you the truth. We're a software company. We're not really a hardware company per se, but there's some advantages to having really elegant software. For one, we realized really, really quickly on that the internal intelligence within SSDs themselves were things that people were kind of using as crutches to change their disk-based architecture into an all-flash architecture. Things like wear leveling, flash translation layer, garbage collection, and such were all the things that were embedded in the devices to make it act like a disk drive, pretty much. Those things slowly are becoming the biggest bottleneck within the system. And in fact, SCSI protocols are by far some of the biggest. And so what we've done internally is we've actually dumbed down the drives, made them as simple as possible, and then leverage highly intelligent software to be able to not only reduce data sets with inline dedupe, compression, pattern removal, thin provisioning, and all data at rest encrypted, but also enable a better metadata infrastructure to be able to do snapshots, 50,000 per system, 1,000 per volume. We incorporate an Evergreen technology, 100% stateless as a whole. We believed that Evergreen was going to be a model that people really wanted to consume by. No longer were you going to have to buy an array every 3 to 5 years. We wanted to come up with a model that allowed you to get credit for your investment, but never rebuy the same terabyte again. Similar to the way that you see it in the cloud today. You're not buying all of those terabytes with a 3-year capital expenditure. You're buying an operational experience of consuming the capacity that you need. And then the last part here is that data is our foundation, just like it is for your guys' business. We take the data and telemetry data that's sent back from our boxes every 30 seconds, and we churn through that data and do a health check on every single array once an hour. We had a PhD from Google that came over, and he said, you realize that a customer has an outage, and then like another customer calls with the same outage? Why would we let our customers do that? We should be calling every single customer that is on the path to have that same outage and tell them they're about to have an outage and alert them of that and maybe even identify the risks. And if we've already fixed it, we should upgrade the firmware to get them there. But most people don't have the data to do this. So our systems actually predict once an hour if you're on the path. And the way we do it is we look at the pathology of an issue. So when you have an outage, we can see over the time period of years even, all of the things that occurred as you are starting to build up towards that outage. We then run against the logs to determine how many people have those out there. And then we open up tickets automatically for customers to let them know that that's happening. Just think about this real quick. Imagine if your car in the morning said the traffic conditions are not very conducive to your driving, and your probability of getting into an accident this morning is about 10 times higher than usual. Did you get in the car? Probably not. And in fact, it would make people get much better drivers because they would be able to see when the best time their behavior would be to actually drive. All of these things are next-gen AI infrastructures that will be built into core platforms that you leverage today, and hopefully longer term your businesses as well. We also believe in data being mobile. Moving data around the infrastructure is quite important. We don't charge for any software whatsoever within the system. Every cool new innovation that we come up with are included with any of our solutions. So we have the ability to do fully active-active across 2 metro environments, asynchronously replicate data off, move it over to a target halfway around the world if you like. We can create local snaps or remote snaps. We can also do this, which is quite fun. You can send a snapshot off to any of these devices. You want to go lower economics, you can go to NFS. You want to go even crazier, you can send it right out to the cloud in a cloud-native format, allowing you to be able to actually leverage that type of application data in a public cloud environment as well. All right, so Evergreen Storage, a lot of people like to dig into this a little bit. I would say it's one of our biggest innovations that we decided to do, and I think we'll be known for well beyond our years. So just imagine for a quick second, you guys go out and buy a house. That house comes with 3 years worth of property tax. In year 4, you get a tax bill that is, for the next 3 years, the same price as a brand new house down the street. Let's think about that for a quick second. What would you do? It'd be quite silly to actually keep your old house. You'd have to move into the new house because financially it wouldn't make any sense. Why would you ever just stay in an old house to pay the same price for the maintenance of that house as a brand new house down the street? Now the downside of doing this is you've got to move all your stuff. You break some stuff, you lose some stuff, your wife or husband's pissed off because you're moving every 3 to 5 years. But this is the process that you get into. We wanted to build a world that looked vastly different. We wanted a world that said you buy 3 years worth of maintenance with that new house, similar percentage as what everybody else does out there. But in year 4, we show up with the same maintenance cost as you paid for the first 3 years, if not less. And while you're at work, we just remodel your entire house for you. So you have the brand new house experience, you never move anything out, and voila, it's great. Seems like a little bit better experience than trying to continue to move and, by the way, rebuy the house every single time. Now, the way we did this was an architectural approach. We became completely stateless from an architecture altogether. No state is left in the controller pairs. We have NVRAM backing the DRAM devices. We have modularity within the chassis itself, so you can swap out either of them. We run an active-passive architecture, which looks active-active on the front because we're all flash, but it's actually active-passive between the between the midplane on the back end. And so what we do for this whole model is you pay this maintenance that you did like in the first 3 years. We give you free controllers every 3 years. Those just show up, and we swap them out over about an hour and a half. That's your remodel of your house. We also created a model that said never rebuy the same terabyte again. So let's put this into practice. Let's say you have an 12 terabyte shelf, let's just say, and you need 30 additional terabytes. At Pure, you don't just go buy 30 additional terabytes. That would be crazy. You should actually go buy a 44 terabyte shelf, pay for only 32 terabytes of which we will non-disruptively evacuate out of the 12 terabyte shelf into the 44 terabyte shelf. You get a 4x increase on density. You get your 30 terabytes that you need, and you only pay for the incremental capacity. We take back that 12 terabyte shelf from you. And so you can do this going on and on and on forever. In fact, we have customers who did this. If you asked me for a petabyte back in 2012 when we first came out with the flash array, we would roll in 6 racks of flash. Today we'd roll in 3 rack units. It's pretty nuts just to see the consolidation factor and the benefits that you get within having to not rebuy the same capacity as you continue to grow is pretty substantial, not only just on the pocketbook from a CapEx expenditure, but also just on power, cooling, and rack space. We talked a little bit about some of the proactive management. I'm going to skip some of this just so you can see what some of this looks like, though. The 2 big knobs that are left in storage infrastructure, we believe, is performance and capacity growth. We built in a single pane of glass management system that takes all that nice telemetry data that comes off of each of these arrays and presents it in a fashion that allows you to predict the future. You get to see this on your phone, your iPad, your home computer. It's all fully accessible. You have your own access rights and such to be able to get into it. But it's accessible without proprietary software. This is running in our cloud. You don't need to upgrade or have folks manage this thing. What if you actually want to do your own kind of systems engineering work? Maybe you want to figure out, I'm going to upgrade some hardware, add some new capacity. You can just go right in the system and actually reset up your forecast based upon newer generation hardware or newer generation capacity right in the interface. What if you wanted to simulate a new workload? Maybe I'm acquiring a new company, or I know that my system's going to grow faster than what it currently shows in the GUI today. I can select that particular workload and then increment that by a certain performance number. I can double it up. I can do all sorts of different scenarios to say one data set may migrate from one array to another array. We also built this in as a single fleet dashboard so you can see your entire enterprise in one single pane of glass. I found it kind of comical that when I got into meetings with the CIO and I asked him, hey, how much capacity do you guys have sitting out there and how much are you actually utilizing? Kind of quickly looks around the room for the one storage admin. He says, what do we have out there? And you could just see the sweat coming. They have no idea. None. In fact, they just guess altogether. And so having the ability to have great analytics here is actually pretty amazing for most folks out there. We also built in a snapshot catalog. You've got data that floats all around there of different capacities as they move around arrays between public cloud and private cloud. This gives you full visibility at a global view of where all of your data resides. And if you want to restore a particular type of that data, it's available to you anywhere out there. This one's probably one of the coolest things that we'll deliver this year. We decided to pull all of the VMware analytics out of vCenter, pump it up into Pure One, and this goes from vDisk to to the VM, to the data for the host, to the data store, to the volume, to the array. I can see full stack analytics for everything: latency, IOPS, bandwidth, reads and writes, CPU, memory, bandwidth, anything I like, all in one view. I call this the quickest time to innocence. Who gets blamed the most for application challenges? It's usually the infrastructure team. The storage guy goes and reaches out to the network. He says it's never his problem. He goes over to the compute guy, and the compute guy says, I don't know what you're talking about. Things look great here. The VMware guy is got a whole slew of stuff on his plate, doesn't want to deal with the infrastructure guy at all. And now the infrastructure guy has got to figure out how to go manage that issue. And so this gives them great visibility into it. We've also seen some great growth around full stack automation. So we've incorporated Ansible, integrations with ServiceNow, SaltStack. We have a Python library. Puppet and Chef are also supported. PowerShell toolkits, over 250 commandlets, all built upon our REST API. We're an API-first business. We also built in container plugins for next-generation microservices applications with Docker plugin and Kubernetes FlexVol integration. All right, so that's kind of where we are today. Where are we going to next? Well, for one, there's some interesting architectural shifts. We've got SAN and NAS as one world, and we've got DAS as a completely another world, direct attached storage, that is. People got out of direct attached storage because they actually didn't want to continue to deal with the fabric attack devices. But there's been a bunch of changes recently. For one, GPUs have gotten big. We've got TPUs, FPGAs, custom ASICs. Networks got really, really fast all of a sudden, 100 gig, soon to be 400 gig. Protocols got much more optimized and efficient with new transport layers like NVMe over fabrics, RDMA over converged Ethernet, and capacities got denser. There's one thing, though, that's interesting. Fast networks helped one interesting fact within storage infrastructure. For one, it reduced the penalty of taking the data outside the box to about 10 microseconds. It also reduced the overhead of CPUs on storage IOs to near nothing. And it allowed for much more disaggregation of distributed applications. So we have a thesis that this is going to converge itself. Your classic kind of virtualization apps and your next generation microservices apps are going to start sitting on architectures that need to be much more efficient. We call this a data-centric architecture just as a whole, or Gartner calls this a shared accelerated storage environment. This is taking highly performant storage, attaching it with super fast networking infrastructure to stateless compute that sits on the top. The value that you get out of these things is you decouple compute and storage, which is pretty spectacular, a win over the traditional DAS environments. You can consolidate at a much, much higher level. But most importantly, as you start to break down barriers of silos for you to actually be able to do analytics across the entire stack. This looks a lot more like what you see in a public cloud, where APIs kind of sit on the left for all sorts of services, and you connect to that via a very fast networking infrastructure. This makes infrastructure simplified. You've got your typical infrastructure today with tier 1 applications, your scale-out apps, maybe running on DAS. You've got all sorts of other tier 2 and file infrastructures. Can now be consolidated down to pretty much this, giving you the ability to be able to run both file and block and object-based services on top of stateless compute connected via a very fast networking infrastructure. The FlashArray//X, which is our newest generation of FlashArray, is a full NVMe-based technology, leveraging those simple drives with highly intelligent software sitting on top of it. This allowed us to do things that were unheard of, getting microsecond-like responses back into the core systems themselves, into the 250 microsecond response time. And then in the future here, you'll see us leveraging NVMe over fabrics via RDMA over converged Ethernet and continuing through that. Also, applications start to get much more performant. We saw Oracle go about 2 times faster, HANA about 3.5 times faster, and Epic environments just going through the roof from an IOPS perspective. Now, when you look at traditional analytics and consolidations of environments in a big data environment, I'm seeing the exact same history play out as what played out in VMware. People kind of threw all of their applications into one tier, one big pool of a data store, and it caused massive contention issues within the system. Flash saved the day there. We're seeing the exact same thing play out here now in a consolidated environment, where people are able to do multiple different use cases: instant restore, data warehousing, big data analytics, and AI infrastructure, all in one core platform, because this is a contentionless platform to be able to scale to any environment. We're also seeing some big changes within the data sets. There are new algorithms out there for deeper learning. We're having much more high densities of computes than we've ever had before through some of the stuff NVIDIA is doing in particular with the DGX systems, where high density compute can now be leveraged in a very small form factor instead of hundreds of racks that you need out there to get there. And people are also seeing that data is now the new oil, the most important thing to their business. But here's one that I think got even more interesting for us in particular. Most learning algorithms got very, diminishing returns as they continued to see more and more data. That's very much changed within new AI methods. Deeper learning methodologies now get better and better predictability with large-scale data. And so the demand to see large-scale capacities is quite important. We also know that there's a huge gap in the need for performance within existing systems today, which are required for deep learning. There has to be better efficiencies, there has to be better transport layers, and there has to be better ways of seeing large-scale capacities to be able to achieve these types of systems. So I thought what would be interesting for most folks is to give you a little bit of a complexity of somebody going into full-fledged production within an AI infrastructure. Most folks have a little system under their desk, they're kind of flirting around, and they realize they kind of have something. To go from that to production is an almost laughable scenario that you have to go through to actually get there. Getting this to be resilient and capable of running an enterprise is quite a bit of a different story. For one, you have ingest data that comes in. These are your endpoints, these are your cars. We see large car manufacturers just take drives out of a car and dump it into a big cluster and then run analytics on top of it. After that, you got to go clean the data set. You got to go say whether it's a cat or a dog in that picture, and you got to go line those up. You got to go say what that particular image is so that the system can actually do some predictability on top of it, and then break them out in various different types so that the system can see it in a blurred fashion, and in the sun, in the nighttime, with lights shining at them. All of these need to be labeled and actually able to run through the systems. The next thing you do is you actually explore the data set. You run your deep learning on top of it, and then you start training it in large-scale production environments. Now, most environments actually have these things all in separate silos. We have a thesis that putting these all together in one common platform enables a full data pipeline. But the reason why most people are scared to do so is the access patterns are dramatically different, which reminds you exactly of VMware back in the day. Throwing them all in the same data store caused major issues from an infrastructure perspective. You see that inject is pretty much a sequential write operation, just comes and dumps it down into a system. You've got clean and transform, which is a very transactional type of environment of reads and writes, small and large. You've got the exploration process, which is pretty random, but it's all reads. And then you've got the training process, which is also highly random, but much more high bandwidth as you're trying to get through the process. We have a thesis that everything can be consolidated onto one platform, enabling the efficiency gains of these types of systems. This looks a lot like the old way of building cars, in fact. Everyone would go and spend time to build the entire car in one system or in one little cubby. They would go run and get their tool for this, and go bring it back to the thing, and they go work on it. They have to go get the muffler. We're going to bring that back, and they would build the whole car right there. They weren't specialized on anything. The data pipeline allows people to flow through the system in a much more efficient way. I specialize as I go down the processes, but I have all of the kind of data flowing directly through that actual system. The bigger challenge here, though, is that you need a storage system that is a Mack truck and a Ferrari all at the exact same time, which doesn't really exist anywhere other than in FlashBlade, giving you inherent performance gains as you add more and more capacity. AI as a whole requires some pretty dramatic infrastructure. For one, you need things that can handle every possible I/O size, every possible workload. You need it to be real-time in its access patterns, elastic and simple, and be an all-flash environment to be able to actually take on those large-scale capacities. It also requires sizable consolidation because there's no way everyone wants to go back to this game of buying 10 to 20 racks of compute and 10 to 20 racks of storage infrastructure. This consolidation factor is pretty dramatic. We've seen even customers do 50 racks down to a single rack at a 50 to 1 consolidation rate on disk to FlashBlade. NVIDIA sees even crazier numbers than that, and you'll see that in Jim's presentation here next. So in order to bridge the gap between the infrastructure teams, who don't know anything about data scientists for the most part, and the data scientist teams who don't know much about infrastructure, we jointly engineered a solution with NVIDIA and Cisco and Arista to actually build in an AI-ready infrastructure to support these systems. The biggest thing that's interesting in ours is we built in a ARI scaling toolkit, which allows for multi-node training and make it simple for anyone to deploy. Remember, going from this under-desk system to production is pretty problematic, and getting there takes a converged infrastructure stack that's been pre-built by two of the leading people within AI, Pure and NVIDIA. Our big goal here, though, was to be able to stream data at the same rate as what we could do in a synthetic environment of building data either in DRAM or actually in the SSDs in the DGX itself. We were able to achieve that, as you can see within these graphs, that we were able to stream data in just as fast as it being natively in DRAM as it attached to a 1.5 petabyte network attached storage system running RDMA over converged Ethernet. And this was a big win for us. Some of the biggest social media companies out there are leveraging these type of AI infrastructures to do all sorts of fun analytics. One happens to be doing a testing to learn the human emotion and understand predictions around suicide and such. We also see many car manufacturers like Zenuity as an example. It's a joint venture between Volvo and Autoliv to be able to create fully autonomous cars by 2021. They're building systems today and haven't been able to do it just with building it themselves, and been deploying AI-ready infrastructure as they continue to scale these environments. We've also seen AHL Man building quants to actually find better analytics around their, their trading infrastructure and where they're investing. And we got to see about 10 to 20x improvement in comparison to what they were building themselves, all within a simple infrastructure stack. All right, well, that was kind of the overall kind of view of things. Thank you very much for the time.
Thank you, Chad.